Hello, everyone. I think we should get started now. I'm Priyank Shah. I'm a software engineer at Hortonworks. I'm here to talk about Streaming Analytics Manager, or Streamline, as you guys might have noticed in the abstract or in the header. We have just decided to use Streaming Analytics Manager now. I am a contributor to Apache Storm, and I'm also a part of the team that worked on SAM and another project called Schema registry, which I'll go over in a little bit. So here's the agenda for the presentation. I'm going to introduce SAM. I'll touch a little over on Schema registry, and then I'll dive deep into the features that SAM provides. And I'll also give you a demo of what SAM looks like in action, and in the end leave some time for questions. So what is it? It's basically a platform used to design, develop, deploy, and manage streaming analytics applications using a drag, drop, visualize paradigm in minutes. It supports event correlation, context enrichment, complex pattern matching, analytical aggregations, alerts, notifications when insights are discovered. I'll go over those terms in a bit, but I just wanted to highlight them in the first slide. It is agnostic to the underlying streaming engine, so we have abstracted away the implementation of the API, but for now we are starting with Storm implementation. And of course, we've taken care of extensibility, so in case you want to add sources, sinks, processors, or anything that the existing built-in components don't support, you can extend it. And the guiding principle has been building streaming applications easily while focusing on business logic. So the goal here is that the developer who's building a streaming application focuses on the business logic rather than the nitty-gritties of the streaming engine. And why we decided to build SAM. So I just wanted to highlight some of the complexities associated with building streaming applications. So first, you have to go through all the streaming engines that are out there, and especially in the last few years, a lot of new streaming engines have been announced, a lot of new APIs have been announced. You need to know the delivery guarantees for each of these streaming engines, the latencies, throughputs. Also, implementing windowing, joins, state management is hard. And on top of that, adding business logic to the streaming application is not trivial because you do have to write code. Other common hassle that we've seen is typically a streaming application doesn't run by itself. It is interacting with other external services like Kafka, HDFS, HBase. And interacting with those services is not very straightforward, because when you build your streaming application, you need to make sure you have the right jars packaged, you have the right configuration files. The streaming application needs to know what is a Kafka broker, what is a Zookeeper server, what is the HDFS name node, and so on. And again, that touches on the deploying part as well. Deploying a streaming application needs to know about all the external services. And once you have the application running, you also need some kind of monitoring using metrics to make sure the latency, throughput, and other application-specific metrics are monitored and actions are taken based on those metrics. And lastly, typically any streaming application runs in a distributed environment, so debugging is not always the easiest thing. So these are the typical complexities that we were seeing from customers or being on support calls. And so the key challenges that SAM is trying to solve here is, so the key challenge is building streaming applications requires specialized skill sets that most enterprise organizations don't have today. Streaming applications, before you put it actually in production, you need to code, test, tune, and that's a significant amount of time before getting it up and running. I think I went over this in the previous slide. Key streaming primitives, such as joining, splitting, aggregation over a window of time, they are not easy to implement. And at times, customers have duplicate code doing the same thing in different places, which becomes hard to maintain. And we've also seen that if there is a cool tool like SAM, people wouldn't prefer to code to build complex streaming applications. And no true open source project today solves all of the above challenges. And as long as SAM offers these UI interfaces to solve these problems without coding, people don't really care what the underlying streaming engine is, as long as their requirements are met in terms of latency, throughput, and there's no vendor lock-in. So SAM has been visualized as being used by three personas: operations, business analysts, and app developer. And for each persona, we have a corresponding module. So StreamOps is the tool to manage service pools, environments, deploying the app, and monitoring it. And I'll go over those terms in the next few slides. What is a service pool? What is an environment? Stream Builder is the UI canvas or palette where you can actually start dragging and dropping sources, processors, and sinks and build your streaming application. And there are a lot of components present in Stream Builder that will let you do various functions like connecting to input streams, which is a source, or any other processor's output stream, applying aggregate functions, and so on. And Stream Insight is finally a user interface powered by Superset, and under the hood it's Druid. So if a Stream Builder app is inserting data into Druid, you can use a Stream Insight module to generate cool charts and graphs and create a dashboard of different slices on a data source. And all those three modules make up SAM. It sits on a unified streaming API, and that API is going to be implemented by a streaming engine. And for now, to start with, we have Storm. SAM's value proposition: a platform using a graphical programming paradigm, allowing users to focus on business logic and easily build, deploy, and manage complex streaming applications. Makes it easier for users to import other service configurations and use them in streaming applications. This is, again, talking about other services. Provides abstractions on the streaming engine used. Like I said, agnostic of the underlying streaming engine because it has an API. Decouples schema from the streaming application via integration with schema registry. So this is an important point. I'll go over schema registry and how integration with SAM powers SAM. And there are operational metrics to monitor streaming application via pluggable metric storage. Examples are Ambari metric service, OpenTSDB. And finally, streaming insights, which is the Superset and Druid module that I talked about to look at the data. Here are some of the key capabilities: connecting to streams, joining streams over a window of time, forking streams based on a simple condition, aggregations, so basically different functions, different aggregate functions over window of time, and streaming analytics, which is descriptive. Descriptive meaning you can look at the charts. Predictive is we have a machine learning model registry as well, and we have a PMML processor. So basically you can add a PMML machine learning model, and you can use that model in your streaming application to score and predict data flowing through your application. And prescriptive is basically when a dangerous situation is discovered, an insight is discovered, you send out an alert or notification. So that's what we mean by that. It also has a simple rules engine, lets you transform your data, filter and route notification alerts. And deploying streaming apps is as simple as just clicking one single button. It takes care of entire packaging of the jars, making sure that all the configuration files are added as the artifact to the jar and in the class path. So all the hassle with deploying a streaming application is taken care of. So schema registry is something that is very critical for SAM to work. And I'll go over why schema registry. So typically, there's a producer that is producing data on some message queue, and that exchange is just a byte payload. And consumer, which is typically a streaming engine, is starting from that message queue and doing some downstream processing and inserting data in some other downstream system. So this is an example of a Storm bolt. So what happens is you read data from Kafka, and there is code that has hard-coded schema. So here you can see we are doing a JSON object.get user ID, get username. and so on. So anytime a schema changes, there is a need for code to be updated, and it is brittle. It is not as easy as it would be if you use SAM. And here's a screen of an aggregate processor from SAM. And what happens is, because SAM is integrated with schema registry, your fields or your schema will automatically be updated in the UI. And for example, if you did a group by on user ID and now that field has changed to user, then all you need to do is go through the UI, go through your app, and just make sure that the streaming application in the UI has been updated and redeployed. So it's a lot easier and quicker. And this is pretty much what I said, why schema registry. Typically, streaming applications start with a message queue, and they are byte payloads that are exchanged. And application developers look into the data using code, change to data schema-wise, needs update. And one cool feature about schema registry is that it also has a UI just like SAM. So it not only supports programmatic schema creation or management, but you can also add schema, update schema. A version of schema is immutable, but you can add different versions using UI as well. So just a brief overview of goals of schema registry: a central repository of versioned schemas that allows producers and consumers to interact and enables evolution of schemas. And what we mean here is that producer can update or upgrade to a different or newer version of schema, and consumer can still consume from the older version of schema. And this can be done as long as the compatibility on the schema is specified as backwards compatible. So you can also specify compatibility at schema level, and we do schema validation when you add a new version of the schema to make sure that the compatibility is still adhered to. So just highlights of schema registry: provide a version schema with compatibility options, define relationship between schemas, enable generic format conversion like CSV to Avro, and generic routing. In terms of operational efficiency for schema registry, schema is not attached to every piece of data. We just have a schema ID and version. Consumers and producers can evolve at different rates. I already talked about that. Higher data quality because of schema validation. And example use case is integration with SAM, where every Kafka topic has an associated schema in the schema registry, and that lets you see all the fields in the payload and apply other functions downstream. So now I'm going to dive deep into some features of SAM. So typical streaming application reads from Kafka, does some processing in P1, applies some window aggregate function, and writes to HBase. So for this, you need to write code. You need to know what is a Kafka broker, what is the HBase server. You first need to write it and test it in dev. Then you need to move it to QA and then production. So there's a lot of hassle and activity that is associated, and it takes time. So to alleviate that, we have something called service pool and environment. So a service pool is essentially just a set of services that you can add or register in SAM. And there is an auto register right now which takes an Ambari URL. So Ambari, for people who are not familiar with Ambari, it's just a cluster. So it manages clusters for Hortonworks. And once you provide an Ambari URL, okay, it will suck in all the services that are managed by that Ambari instance and register with SAM. You can have multiple service pools. And once you create a service pool or multiple service pools, you can create an environment. So you can say, this is my dev environment, this is my QA environment, or you can even mix and match between the two service pools. So that's just a diagrammatic view of service pool and environment. So we have created two environments by mixing services from different service pools. And this will be more clear when I show you the live demo. So this is how the service pool looks like. As you can see, there is an auto add, which is the Ambari URL that I was talking about. And we also have, in the next version coming up, a manual service registration where You don't need an Ambari cluster, or you can register any service manually. And once you click on the manual button, it will take you through to some other screens for different types of services. So for example, Storm, it will ask for a storm.yaml and so on to be able to register those services. And before I forget, so if you want to know more about Schema registry, there's a talk tomorrow by Satish. So I encourage all of you to attend that. Yeah, so this is how environments look. So once service pools and environments are ready, which should be a matter of a few minutes, you can start building your streaming application. And to build a streaming application, we have these builder components. For source, we have Kafka, Event Hub, HDFS, all integrated with Schema registry. For processor, we have join, window or aggregate, rule, normalization, projection, branch, PMML, and custom. I'll go over each of them later in the demo. Syncs, as you can read, those are the syncs that we support right now. So here's what a streaming application looks like in SAM. So this is the stream builder module that I talked about before. And I'm actually going to use this app in the demo as well. So I'll go over the details of that app. This is the dialog for join processor. And if you look at the input here and all the fields, and you have types for those fields. So that's coming from Schema registry at the source. So Kafka is the source. There is an associated schema. It sends data to the next component, which is join processor. So that's how you see the schema coming from Schema registry. And here you are joining two Kafka topics or two sources and saying, this is how my output should look like. And once you deploy the streaming application, this is the view mode. This is where you can look at some of the metrics while it's running. And finally, the streaming analytics or the stream insight module that is powered by Druid and Superset, which basically provides a tool to business analysts to do descriptive analytics of the streaming data and perishable insights using a sophisticated UI provided by Superset. So I'm going to show you some charts as well in Superset. And also basically provides tooling to create time series and real-time analytics dashboards, charts, and graphs. So yeah, this is a screenshot.
Can I ask a question?
Yeah, sure.
Can you go to the previous slide? The previous. Here you said input is Kafka stream. Does it mean Kafka consumer?
No, it's the stream abstraction of SAM that we have.
So what does it mean exactly? Okay, if you choose instead of Kafka, can I choose Flume as well?
No, Flume is not a part of it right now.
Okay.
Do you mind if you leave the questions for the end? Thank you, sorry. So yeah, that's a screenshot of the dashboard that I was talking about. And this is a fictitious data that we use to create a streaming application and insert into Druid. SAM SDK, this is where if you can't do what you want to using the components that we ship, in that case, we provide a custom processor interface. It is basically a part of our SDK. You can implement this interface, register it with us, and start using it in our streaming application. Aggregate functions for window or aggregate processor. We ship built-in functions that I've listed here on the right, standard deviation, variance, and so on. But if you want to provide your own custom UDF, user-defined function, excuse me, then you can register that with SAM as well and use it in the streaming application. Notification sync is for sending out notifications or alerts when you discover an event or an insight that is dangerous and need to act right away. So we ship an email notifier by default that works with notification sync, but that is also pluggable. You can provide your implementation of the notifier, which could be sending a text message or writing to some storage, inserting a row in some storage. So what's next? Manual service pool registration, which I already talked about. Instead of providing an Ambari URL, register it manually. Test sources and sinks. So if you want to test your streaming application, then you can build it and then you can say test. And what it will do is replace all the sources with test sources and prompt user for data for each of those test sources. And for each of the sinks, it will replace them with test sinks and write the results into a temporary file. It will also record these results in a table in a historical fashion, so you can go back and look. So it just makes it very easy to test the functionality of a streaming application. We already have some pull requests up. We are adding authentication and authorization. We'll start with Kerberos and a simple authorizer. And of course, other components as needed. Kinesis is next in the sources category. So now I'm going to give you a demo of how it looks. So I'm going to start with creating a service pool. So this is where you go and click on service pool. And I already have an Ambari cluster. So I put the Ambari URL, I click add. I provide the password, username and password for Ambari. And it will basically suck in all the services from Ambari. And this is very useful and how I'll show you when we actually build a streaming application. But because it knows that this is a Zookeeper cluster, this is a Kafka cluster, it can make suggestions for topics. So you can, it's like an auto suggest. So you'll get a drop down of all the topics in that cluster, so you can pick one instead of manually typing it in. It'll know the Zookeeper URLs automatically and so on. So this is creating a service pool. Now let's create an environment. So I'm just going to name this Munich demo. And I can pick services that I want from the service pool that I have. And this creates an environment. And once an environment is ready, you're all set to build a streaming application. Now I'm going to switch to another cluster because it has a lot of other services installed that we need in the app. So this is the cluster. And I'm going to, so this is where you create a new application. So these are the applications that have already been created. And this is where I pick the environment. And as soon as I do this, I'll get a blank canvas. So to begin with, I'm going to drop a Kafka source. I'll double click to configure it. Now, if you look at the Zookeeper connection URL, it is all automatically populated because it knows that this is a part of this environment which has services from this service pool, so it has to be this Zookeeper URL. And it is an auto suggestion. You can always change it if you have multiple Zookeepers, for example. There is a drop down for all the topics in that Kafka cluster. So just to give you a little background, this is a sample or fictitious data that we ingested in the topic. So there are two sources. One, so they are both coming from a truck that is going on a route, and two types of events. One sends a truck event, which could be a speeding violation or unsafe tailing distance or something. And other is the speed of the truck. And both of them have driver ID as a common field, and they have other fields as well. So as soon as I pick a topic here, you can see on the right side in the output, you can see the schema of that topic. And this is where schema registry comes into picture. Each topic has a schema, and it will connect to the schema registry and show you the fields. So I added one Kafka source. I'm going to add another Kafka source. So for the previous one, it was the events, truck events. Now I'm going to pick the truck speed events. And I'm going to use the join processor. So to answer your question, this is, so basically there is a stream abstraction for us. So we are saying the output stream of that Kafka source and this Kafka source I want to join. And for join, you need to provide a window. So let's say 30 seconds. And you basically say, I want to join on driver ID. So that's what I'm doing, inner join and left join. So we pick driver ID from both the streams. We say 30 seconds window. And we also select output fields. So you can select as many fields as you, so I'm going to put all of them for now, but you don't have to. You can just pick the ones that you want. And you click OK. And that's your join processor. And now let's say I want to aggregate. I want to calculate the average speed over the last 3 minutes. So all I do is connect the join processor to the aggregate processor. And I say, so driver ID and driver name, select keys, these become my group by keys. And I'm going to say a window of 3 minutes. And I'm going to say a group by driver ID, driver name, and give me the, I'm looking for the speed. Okay, so give me an average of speed, right? So if you look at the output schema, so you see how at every point the schema is changing, starting from Kafka to join to aggregation. So we now have driver ID, driver name, and average speed. So once you have that, you can add a rule. I'm looking for the rule processor here. So now we can say if average speed, add new rule. I'm going to say speeding violation, and I'm going to say if average speed is greater than 80. And this is a simple user interface, but for advanced SQL, we'll eventually provide you with plugging in your own SQL. So we now have created a rule processor. And so you see the point. You can add processors, sources, sinks, and do whatever you want. Because I want to show you another cool feature, and because I already have a streaming application built with a lot of stuff, I'm going to show you one feature. So any streaming application that you build, you can export it, and then you can import it, and you can associate it with a different environment. So dev to QA and production, you can do all that stuff. So I already have a topology, a streaming application which is exported. So now I'm going to show you how to import that and just run it in a single click. So I'm going to import an existing application that was already created by the export feature. And I'm going to say Munich demo 2, and I'm going to associate the dev environment, and I'm going to say OK. And once it imports, you can see it brings the entire streaming application in front of you. And this is pretty much what we went through, 2 different Kafka topics, speed and event, join, add a rule. And this rule here is basically saying if the event type is not normal, which means it's an infraction, it's a violation, you straight away insert into Druid, and then you do the average speed aggregate processor. Then you create this rule for average speed greater than 80. And then if the average speed is greater than 80, then this is the notification part. And it needs some details to be plugged in because you need to connect to a mail server and provide credentials. But you can provide an email body like this. So you can see it is parameterized. So when you provide dollar parenthesis driver name, when actually a rule is fired, it'll replace the driver name with the data that's coming in and the speed with what it was calculated in the aggregate processor. So that's the notification sync, and I'll just click run on it, and you should see it being deployed in a few seconds. So it's basically creating a jar, packaging the jar, other artifacts like XML files needed for accessing other services, and it's submitting it to the underlying streaming engine. And yeah, so once it's done, you go back here. This is a read-only mode. So you see some metrics here. You see when you click on it, you can even hover over and see how the schema is changing. So this is a read-only mode like I mentioned before. So here, this is a schema. After the join press processor, this is the output. So every point we show input and output schema so that you can see how the schema is evolving. And this at the core is powered by schema registry at the source. And yeah, so if you go to Storm UI, because the underlying streaming engine is Storm, you will see that this application is running, uptime is 41 seconds. So it was so easy and quick to deploy that streaming application. And now I'm going to show the streaming inside the dashboard, just to see what kind of visualizations you can have. So because we are talking about violations, speeding violations, unsafe tail distance, and so on. So we have on the right side top violation drivers. Higher the number, bigger the font size, I think. We have total violations in last hour. And this data is stale because we ran this a week or so back. It takes a while to warm up. So, but basically, as soon as your streaming application is up and running and ingesting data in Druid, your dashboards that you have already created will update. And it depends on how Druid is configured and how you're using it as well. But so this is another chart where you get breakdown of violations. So the innermost is by driver. So within that driver, so it's saying 47.7% of total violations are by Suresh. Within that 47.7, 15.4 are unsafe following distance, 11.7 are overspeed, and 10.6 are unsafe, and so on. And even one more level down, you have the route for that particular type of violation. There's one more chart here, which is basically the routes with highest violations. But yeah, I think this is pretty much what I wanted to cover in the demo. Actually, one more thing. So I mentioned about custom processor. So we already have a user interface for custom processor. We have a processor registered. I'm just showing you the edit screen for that. So you can see you can provide the fully qualified class name, supply a jar file, give its input and output schema, and when you go to the streaming application, you will see that. So I'm going to go to the edit mode here. So that custom processor is going to appear here. So this WebSocket sync is actually a custom processor. So if you register one, it will start showing up in the palette. You can plug it in your streaming application. Yeah, I think that's pretty much it from a demo point of view. And I think there's one last slide which I wanted to cover. We should be quick, and then we can go to questions. But so SAM is open source under Apache license. That's the GitHub repo. Apache incubation coming soon. SAM 0.4 is already out. That's the Google groups where all the discussions and the roadmap and everything about SAM is going to be discussed and decided upon. So if you want to participate, give feedback, or even contribute, that will be great. We are looking for contributors, so please go ahead and ask for being a participant to that group. So yeah, that's it from my side. If you guys have any questions, let me know. I think they want to record it, so that's why I need the mic. So I can't. Yeah, I want to make sure she is recording. Is that?
Yeah. Okay. Thank you for the presentation. Can you please show us how do you test your topology? You said that you have this mechanism for generating data.
Yeah.
Test the whole topology.
So yes.
Is it not too cumbersome, of course?
No. So it is not about being cumbersome, but if you, I mentioned it in the what's next slide. So we have a pull request. Actually, the pull request is even merged, but it's not a part of the release that I'm demonstrating. So unfortunately, I cannot show that. But it is merged. It is in place already.
Okay.
I can show you. I can send you the link to that pull request if you want.
Great. Thank you.
Yeah.
See, the dashboard where we can see the flow from Kafka to your SAM and implement some applications and store it somewhere like Space or status or whatever. So it is in a real time. As we know, if there is the source and target, if there is a big lag, like if we are lagging to consume Kafka topics, or we are joining two Kafka streams, but one Kafka we are significantly lagging, that kind of alerts or notifications. Say example, one copper is not up to not up to date, something like that.
Right, so I think what you're talking about is the late arrival of events in a window. So I think that is more specific to a streaming engine. So in this demo, you can the presumption is that they are.
The question is, will that information will be known from SAM, or I got to go to the Storm UI and you have to check it?
It will be known. Right now, I think there is no clear way to know that, but it will be exposed.
So this is this is a pretty cool. I've never, from an open source perspective, I don't think I've ever seen a user interface on top of a streaming engine. So very, very cool. So you talked about from an operations persona, this tool can help folks. Can you maybe give a little bit more details from a metrics perspective, what this tool can show?
Yeah. So the metrics basically. Let me. So yeah, as you can see, number of tuples emitted, transferred, latency, capacity. So these metrics are coming from Storm, and you can basically make sure that your topology, because underlying streaming engine is Storm, your streaming application or the underlying topology is actually performing at the speed that you are looking for. Or
can you drill down into like an individual component to see a bottleneck or anything?
Yeah. So let me, the component filter here.
Oh, okay, very cool.
So yeah, that's at component level. So at each component, you can basically see what is the input versus output, number of act tuples, failed tuples, and so on.
Cool.
Yep.
Are monitoring related pull requests welcome? I mean, Prometheus support would be awesome in this.
Sorry, can you please repeat that?
Prometheus support would be awesome in this since we are using that one as well. And are those kind of pull requests also welcome for you?
Pull requests for superset, you mean?
No, Prometheus monitoring, exporting these metrics via a given protocol for a monitoring system.
I don't think those pull requests would be a part of this. But basically, you need to provide a implementation of the metrics interface that we have. So as long as you provide that implementation.
Okay, anyway, okay.
Okay.
Thank you for your presentation. I have a question about NiFi. Is there a integration with with SAM that is planned for NiFi to manage schema?
Yes. Yes. So I don't know if you're familiar with HDF offering. So HDF offering from Hortonworks has Apache NiFi, SAM, Storm, Kafka, and Ambari and other services, and Schema registry. And what you saw in the Kafka topics was actually inserted by NiFi. So NiFi is integrated with Schema registry. So when NiFi produced the data, it actually published a schema because NiFi was the processor. So NiFi is basically for handling and moving data from edge to your data centers and Kafka clusters. So yes, NiFi is a part of that.
Thank you.
Hi. Can it be used with Spark structure streaming?
As of now, no, but we'd love to have support for another streaming engine as well. And if anyone's
is it plain?
Sorry?
Is it plain?
Not right away, but if anyone's willing to contribute, we'd be happy to talk about it, even after this presentation.
Thank you.
So,
Just with the join criteria. Hi. Just with the join criteria there, if say for an operations person wanted to update the criteria there, does the topology need to be brought down and killed first, or does it load it back up on the fly?
You need to kill and redeploy the topology.
Okay.
Yeah.
Right.
Because it is under the hood. Eventually, it is changing the code. The only ease of use is instead of you having to do it, SAM is going to do that for you, repackage and resubmit it.
That'll be a feature of Storm though, but I think Storm 2.0 has that feature coming soon, right?
Oh, okay.
Yeah.
Yeah.
That would be okay. Good.
Yeah. Okay. So yeah, anyone has any questions? I'm here today and tomorrow. So.